To dilate a shape on a graph, all you need to know is the scale factor and the points of the original shape. So let's see what it looks like to dilate this original triangle ABC by a scale factor of 2. So what we're going to do is for each of these points, we're going to multiply the x value and the y value by 2, and then we're going to graph the new resulting point. So A is originally the original point A was negative 2 comma 1. So to get our new A, so we'll call it A prime using this notation, our new A prime is going to be negative 2 multiplied by 2, which is negative 4, and 1 multiplied by 2, which is 2. That's it. And we can go ahead and graph that new point A prime as well at negative 4, 2, and we'll label it as A prime. Next, we can so basically we'll repeat this process for each of the points in the triangle. So the point B is originally 1, 3, so we'll do the same thing. For B prime, we're going to multiply the x by 2 and the y by 2. So the x value is 1 times 2 is 2. And for the y, our y value is 3, so 3 times 2 equals 6. So our B prime point is 2, 6, and we can graph it right here, 2, 6. So the original B was this, and now it's out here. And last, we have our C point. So our original point C was at 3, 0. Same process. So we'll multiply 3 times 2 to get 6. And we'll multiply 0 times 2. Now 0 times anything is still 0. So 0 times 2 is 0. And we're done there. We'll graph that point. 6, 0 is our C prime. And now we can connect these 3 dots and we'll have our new dilated shape. So whenever your scale factor is more than 1, you're making the shape bigger. This kind of makes sense, right? Each of these numbers got doubled in size, so it makes sense that our shape would also grow or get larger as well. Just so you can see this with another scale factor of 4, we could do the same thing again. Now I'll use the double prime notation to show that this is yet another new shape. So again, going back to the original points, negative 2 and 1, if I multiply each of those by 4 this time, I get negative 2 times 4 is negative 8, and 1 times 4 is 4. I can do the same thing for B. B double prime is going to be 1, 3. Again, multiplied times 4, so 1 times 4 is 4, and 3 times 4 is 12. We're going to go off the grid here, I think. And for C double prime, we have our original C, which was 3, 0. 3 times 4 is 12, and 0 times 4 is still 0. So if we graph those points, we'll have negative 8, 4. So there's our new A double prime. We'll have 4, 12, and I'll just add a few more notches on my y-axis here. So that's 9, 10, 11, 12. So B double prime is at 4, 12. It's somewhere around here. And C double prime is at 12, 0. So we'll add some notches on our x-axis as well. 10, 11, 12. So that guy is going to end up about right here. There's our C double prime on the graph. And again, we can connect those points to get our new dilated triangle. And as you can see, the bigger the scale factor, the bigger the dilated shape. So whatever number it is, you just multiply that times the x and y values of each of the points, and you'll have a new dilated shape.